Hey, it's Tony from Adafruit, and this is a look at how to install MicroPython on the ESP8266. So a little bit of a break from the regular kind of Raspberry Pi related video streams that I'm doing. I think all this month I'm going to do a bunch of MicroPython related streams. So stick around though if you're a Raspberry Pi user, because I think you'll find MicroPython pretty interesting. If you use Python on the Raspberry Pi, MicroPython is a really cool version of it that you can use on little microcontrollers. And I did a really good little intro video of what MicroPython is. I'll put a link to it below in the description when this goes up on YouTube. So if you don't know what MicroPython is, check out that video. It kind of walks through, shows a lot of demos and examples, links to a guide that explains the same thing. So really cool thing that we're going to look at. And so this video will probably be pretty quick because luckily the process is pretty easy, but I wanted to show how to load MicroPython onto the ESP8266, which is one of the boards that MicroPython supports. There are other boards, and if you go back to that first video I talk about them, there's boards like the Pi board or the YPi or the Microbit. And those actually aren't that complex to get set up with MicroPython. Like the Pi board and the YPi actually come with MicroPython running natively, so you might never really need to at least load the firmware. If you want to update it later, obviously. But the ESP8266, it's sold as, really like a serial Wi-Fi interface originally, but everyone has kind of taken it and, they've extended it and used the SDK. So now you can program it like Arduino and stuff. And you can program it with MicroPython. So I wanted to show though that in order to use it with MicroPython, you have to do a little bit of setup, and it's pretty straightforward and simple. You load a firmware onto it that runs the MicroPython interpreter. And then at that point, you can start running MicroPython code. You're ready to go for that. So let's just kind of dive in. I'll jump into the main view here and we'll see desktop and everything. So over here in the corner upper right, I've just got, this is the Feather HUZZAH ESP8266. I'll put a link in the description below. Really nice little ESP8266 based board. Now you can use any ESP8266 for this though. You could use the raw modules that are like $2 or $3. They're a little annoying to use with a breadboard. They have like this, I think 8-pin header that you've got to break out the wires from. But as long as it's got at least the serial connection and power and ground, then it should work. But you'll need some kind of USB to serial converter. The Feather HUZZAH is nice in that it's got everything built in. So you plug in a serial cable right here, or a USB cable rather, and it's got a USB to serial converter chip on here, Scilab's chip that's real easy, simple to use. Just have to install a driver, which I'll show you real quick. But then this is a nice little board, nice feather form factor. But the ESP8266 is the main attraction there, and so that's what we're going to load MicroPython onto. So not much is going to happen with the hardware here, unfortunately. This is mostly software stuff. And then I'm showing right here, this is a guide. It's not published yet, but should be published tomorrow. And this is a walkthrough of how to load MicroPython and load the latest firmware for all the different boards. So we're going to look at the ESP8266 right here. But like I mentioned, the other boards, there are instructions in this guide, and there'll be a link in the description below when this goes up on YouTube and the guide's published so that you can see this guide. But basically the Pi board, the YPi, those come preloaded with MicroPython, so you probably don't need to do much. But if you do want to update them, I give some instructions there. Microbit is nice in that if you use their online code editor or even their offline code editor, it will actually combine the MicroPython code that you write with the firmware so that it just gives you a single firmware file. So every time you use their code editor, you're reloading the latest MicroPython firmware effectively with it. So that's kind of handy. And then the Teensy, I actually just kind of briefly mentioned, maybe I'll link to the page here. So I'd say Teensy is for advanced users right now. There is a Teensy port of the MicroPython project, but you need to know how to set up an ARM tool chain. The instructions are a little bit stale. There's no pre-built firmware because it's kind of still in an early stage. So if you want to hack around with MicroPython on the Teensy, you're going to want to probably know how to compile code for the Teensy, outside of Teensy Arduino and things like that. So advanced users only, I'd say for now for that. And the port, again, is still kind of in the early stages. So, if you really want to get started with MicroPython, I'd say stick with the ESP8266 or the Pi board or, the YPi or one of these boards that's got it kind of running easily or has a pretty built out port of it. So let's just get started then. We'll start walking through this guide, and it should be pretty quick. I think hopefully this will be under 30 minutes. And just to start with, I talk about there are official instructions. So that's right here, the official instructions for MicroPython on the ESP8266. And we're really just going to run through these. So if you run into any issues with the guide or whatever, go back to the official instructions. Sometimes things change over time, but generally this is what you're going to need to use this. And so to start with, you're gonna need Python 2.7 installed. And unfortunately, you have to have Python 2 because this ESP tool that we're gonna use, at least the versions of it that I've used, require Python 2.7. Luckily, it detects if you try and use with Python 3 and it fails, so you get a nicer error message, but you know, unfortunately, an old tool like this, although it's not that old, so you know, hey, we're 2016 and we still aren't in Python 3 yet. So, okay, anyways though, so install Python 2, go to python.org. Now, if you're on Mac OS 10, you've probably got it installed already. It kind of comes, Apple has a version of Python. You just open up a terminal and run Python. And if you get a prompt like that, and make sure that you see Python 2.7 something, you know, like .9 or 11 or whatever, then, you know, you've got Python installed. For Windows, you will need to install Python though. So, you know, go to the download page. They'll have a download. Again, make sure to get the 2.7 version. And I remember when you install Windows Python, there's a checkbox that says, do you want to put Python in your system path? You probably want to check that because that makes it easy so that when you open a terminal, you can just run Python and run the pip command and it's just going to work. If you forget to do that, you're going to have to add it to your system path and then like restart your machine or open a new terminal to get it active. So, you know, just beware that you need Python in your path for this to work. And then let's see, let's go back. So once you have Python 2.7, then the magic command that you want to run is pip install esptool. Or on Linux or Mac OS 10, sometimes you might need to use the sudo prefix to that to run as root. It just depends how your distribution is set up for installing packages and things. Now on my machine, I'm using Homebrew on Mac OS 10, which installs its own version of Python that's unfortunately separate from the Apple version, which causes a ton of confusion on OS 10. And it actually causes a problem here because I also have Python 3 installed, and so for some reason my version of pip uses Python 3. So if I try to pip install esptool.py, we're actually going to see it's going to fail, or oh geez, that's oh, I'm sorry, I just ran the wrong command. Pip install esptool. We should actually see. I get this cute error, esptool only supports Python 2.x. So if you're on Mac OS 10 and you run into this error, you're probably in the same situation as me. Luckily, the fix is you want to run the pip2 command, sorry, not pip3, pip2. That's going to explicitly use Python 2.7 and then install esptool. And this should work. And so this kind of goes through, and I've already got it installed. But it's this is what you want to run. So, you know, try pip install esptool. If that fails, try pip2 install esptool. If that still fails, you might need to add sudo. So like sudo pip install esptool. So unfortunately, that's a little complex, but you know, just follow that process and eventually you'll get it installed. The Python kind of distribution world is it's better, but it's still not amazing these days. So okay, so it's installed, and if you just want to check, run esptool.py -- help, and you should see some help info about this. So, you know, here's v1.1 of this tool. So everything's good. And it basically, when it installs, it puts this esptool.py program in your path and makes it so that you can use this tool. Really, really handy tool for talking to these ESP8266 chips. So, okay, so that seems pretty straightforward. Now the next thing, we want to download the latest MicroPython firmware. So let's go to the web page here for MicroPython. And this shows, here's the ESP8266 build. And you might wonder, okay, so here's all these version numbers here. These are kind of the different published versions of the firmware. And there's the top one is usually the latest. And if you see these weird little kind of, I guess they're hashes at the end here, I believe these are the GitHub commit hashes. So like if there were multiple builds in a single day or from a single version, I guess, they must just throw the hash on here. Long story short, you probably just want the latest version, so grab that one. It's nice that they've got older versions in case you want to fall back to those. So okay, so we'll grab this, and I think I've already got it downloaded. It's just a small little .bin file. Cool, okay, so that's downloaded. And then let's go back and see what else we need to do. Okay, so the next step here, so now you're going to need your board and you're going to need to connect it to your machine. And I mentioned here it's different for each ESP8266 because you might have the raw ESP8266 module, in which case you're going to have to wire up a GPIO 0 and a reset line button, or at least like connect those to ground. Because basically the way that you tell the ESP8266 that you're going to program firmware is you have to pull the GPIO 0 line down to ground. And while that's held down to ground, you reset the chip. So you pull the reset line down to ground, and then you release it so it goes back to like a floating or a high level. And then at that point, when it reboots, it sees that GPIO 0 is held down to ground, and it goes into that firmware flashing mode. And then you can release GPIO 0. So kind of a weird process, but if you've ever used ESP8266 Arduino, then you kind of know this process because you have to do this every time you load a sketch. If you're using the HUZZAH breakout, which is the older version of the HUZZAH chip, not the Feather form factor, it actually has buttons for GPI 0 and reset. So what you have to do is you hold GPI 0 and then you press and release reset while you're still holding GPI 0, and then you release GPI 0, and that'll put it into the firmware flashing mode. And if I remember correctly, I think the blue light and the red light both turn on the module, so you'll see, you should see something change on the module, like some lights come on that tell you that. Now, luckily for the Feather HUZZAH, real nice thing about this board, it has a small bit of logic on it so that it can detect when the serial port opens, and it can actually automatically put the ESP8266 into that firmware flashing mode. So you don't need to do anything. Like, you literally just run the command and it just works. So again, another really good reason to use that chip or that board. But one little note here, and I put it in bold, you do need to install a driver for this on both Mac OS X or Windows. On Linux, at least the current Linux kernels seem to have this driver. But for Mac and Windows, make sure to install this and just go to Scilab's page. Very straightforward and simple. Download the VCP driver. VCP usually stands for like Virtual COM Port. So download that, install that. They've got it for every platform here. So grab that, get it going. Because ultimately you want to find out what's the serial port for your device. So I have mine plugged in. And the way on Mac OS X, you can look at all of the TTY devices. So tty.star, excuse me. And the same thing works on Linux. So all of your serial ports are under the /dev/tty hierarchy. So if you do a command like this, you should see some devices. So I have my board plugged in. If I unplug it, I just want to show you that this is a good way to detect. So I don't have it plugged in. I look at the serial ports, I plug it in, and then I look at the serial ports again, and we'll see that, hey, look at that. There's the Scilab's chip right there. So that's a good way to figure it out. On Windows, you want to look in Device Manager. Open up, press the Start menu button, and then start typing Device Manager, and it should pop up as the first entry. Go into that, and then that's going to show every device connected, and there's usually a COM port, C-O-M, COM port. Look at that, and that's going to list all the COM ports, which are like serial devices, and so look for those when you plug and unplug your device, and you should see it appear there. So okay, so we know our device, it's got a serial connection here. So let's do the next step. So the first step, when you're upgrading or installing the firmware, they generally recommend you want to run this erase flash command. This just wipes out everything on the MicroPython or on the ESP8266, because sometimes it stores some state in the flash memory. So things like if there's a password for the web REPL or other certain things, or like its little file system. So usually if you're upgrading the firmware, it might make a breaking change so that like the old state isn't compatible with the new firmware, and that can cause all kinds of bugs and issues. So best practice, erase the flash memory, but just realize like if you had files and things on there, you're going to lose those. So be careful. Okay, so the command here is pretty easy. We're just going to run esptool.py, point it at the port or like the name of our serial device, and then run the erase flash command. So let's do that. Let's see, esptool.py port dev tty.scilabs, and then erase flash. So I run that and it connects, and you notice a few things little like flashed. It erased the flash, and that's it. So pretty straightforward, not much drama. Okay, the next thing now is the final step. It's this easy, just two commands. So we're going to use that esptool.py command again. This time we're going to use the write flash command, and we're going to point it at the firmware file. And so this kind of shows the command line that you want to run, and you give it a baud rate, like how fast it can flash the chip. So let's type this in. I'll kind of move this maybe out of the way a little bit here so we can see this. Okay, so esptool.py, give my serial port again. And then I'm going to give the baud rate, and so this is 460,800 baud. Write flash, and then flash size. So this is how much of the flash memory to write. 8, I believe this is megabits. This has to be megabits. It couldn't be bytes. And then the next thing is 0. So this is where to start writing the flash. Basically, position 0 in memory. You know, start from the beginning of the flash memory, and then it's just going to write all of the firmware data that we have. And then you point it at the .bin file that you downloaded earlier. So this is the ESP8266. Let's see, for me, I have an 0816, it looks like. Let's grab that one. There we go. So this, basically whatever the latest firmware file was that you downloaded, you want to put in here. So, okay, so we'll grab that, and I'll press enter. And notice things are happening here. So you can see like a little blue light. Well, you might be able to see. There we go. So you can see flashing blue light. That's kind of telling you that the module's being written with new firmware. And you can actually see it's got a nice little progress indicator here. So it's pretty quick. It's just going to finish in a second. Okay, so it wrote the memory. Okay, so we're pretty much done. The last little thing that I mentioned is you want to press the reset button. I've noticed you need to reset the board before you can connect to the serial connection. So I'll press the reset and reset the board. And then at this point, you're done. You've loaded the firmware. Nothing failed, so everything should be working. And then the final test will connect to the Serial REPL. And so I have a little page in the guide where I just mentioned this. And again, you make sure that you've installed the drivers because you won't be able to access this REPL if you didn't install drivers ahead of time. So I mentioned each board is kind of different. Some of the boards need drivers, some of them don't. So I mentioned that there. And then I also mentioned, so on Windows, you're going to want to use PuTTY or any kind of a serial console tool. PuTTY is probably the easiest because you need to open up those COM ports and have a terminal with them. On Linux and Mac OS X, it's a little easier because the screen command is built in. Or if it's not, you can probably get it from a package manager. And so that's what we're going to use. And the screen command here is a real simple little text console. So let's use screen, and to use that, we just point it at the serial port again. So this is dev tty.slab USB to UART, and then you have to give the baud rate, and for MicroPython it's 115200 baud, and I do that. And sometimes when you connect you don't see anything, but just press enter and you should see this. So this is basically telling you that you're at the REPL, or the read evaluate print loop. And so this is like the Python terminal. So you could say like print hello world, and hey, look at that, you got Python code. The other thing, if you connect and if nothing is happening, so like let's say this, I'm gonna make a wild, how about this, I'll import time, so we'll just have like a delay, and I'll throw it in an infinite loop, so just while true time.sleep for a second, and then just let it run. So now my chip, it's running some Python code, and I'm gonna quit out of screen, so I press Control A, and then I learned this recently, if you type :quit and then enter, that will actually let you quit. Another way is Control A, then press K, and then press yes. It's always weird. Some of these GNU tools, you just have to learn how they have keyboard commands and things. It comes from an older Unixy world that I'm not as accustomed to. But anyways, so let's say you connect to your board and you're pressing enter and nothing is happening. Like, look, I've connected, and it's like, where's the prompt? So luckily what you can do, try pressing Control C a couple times. So I'm going to press that, or I just pressed it once, so you might need to press it a couple times, and that will interrupt whatever code is running. So just in case if you had a script that was running and you can't get to that REPL and you just want to stop everything, press Control C, and that should get you back to a REPL. And I've noticed sometimes you might need to press it a couple times, but this will get you back, and then you're back in business here, and you can go crazy with MicroPython stuff. So that's basically it. That's how to load MicroPython on the ESP8266 with the Feather HUZZAH board, but this really should work for any ESP8266. You saw it's pretty straightforward. You just need Python and a little tool, and then some firmware files that you can download now from micropython.org. So they publish these. I think they're built daily. And I just want to mention too, one last little thing. So, in the instructions here, I mentioned that you can download the pre-built firmware. Now, if you're really advanced and want to start hacking on MicroPython and maybe using like the latest code in GitHub, if it's if they don't have a firmware file built for that yet, or maybe you want to add code to it and like build your own version, I do have a guide, and I'll put a link in the description below. This is actually the first guide that I did on MicroPython. And this is how to build the MicroPython firmware in a little Linux virtual machine. So you can do this on Windows, on Mac, or whatever. And it just tells you how to install a tool called Vagrant, which runs virtual machines. and then make a little Linux machine and install the ARM tool chain that it needs, or it's not ARM, it's like the Extensa or Extensis chip. But install the tool chain to compile code for the ESP8266, and then install the MicroPython code, how to compile that code. Sounds really complex, but it's not too hard. You just run a few commands, takes a little bit of time, and it'll just pop out the latest firmware code compiled, for you. So if you add things to it, if you add your own code, you'll probably want to look at this guide to build the firmware yourself. But you don't have to. If you just want to get started, again, go back to the how to load MicroPython on a board guide that I mentioned, and just download the pre-built firmware. So it'll make things a lot easier for you. So that's it then. If there are any questions, I don't see a lot of folks in the chat, so probably no questions. We'll jump back to the main shot here. And apologies if it gets glitchy in this shot. I need to troubleshoot some Wirecast issues. But anyways, yeah, so I'll wrap it up. I don't see any questions. This was how to load MicroPython on the ESP8266. So check out the guide that I mentioned. There'll be a link in the description below, and you can go look at that. And it might not be published until tomorrow. So if you're looking at this on YouTube, if you're looking at this on YouTube on August 15th, maybe wait a day, and it should be there tomorrow. But anyways, that's all I wanted to show. And check out youtube.com/Adafruit. You can see this video and all kinds of other fun videos, like the last video I did on just what is MicroPython. So again, I'll have a link in the description. You can check that out. I like to do a couple videos or a couple live streams every week, so check out twitch.tv/Adafruit, and you'll see different live streams. You can watch me do these things live. And I've done a stream, like I said, last week on what is MicroPython. And I'm thinking, so normally I was doing Raspberry Pi streams, but I think this month I'm going to do MicroPython streams. But like I said, if you're a Raspberry Pi user, stick around. I think you'll find MicroPython pretty interesting. If you've used Python on the Raspberry Pi, you can use Python on little microcontrollers, and it's really cool. So we're going to explore that further this month and see what kind of fun stuff we can do with it. So anyways, look for videos. Usually on Mondays I do a video, and on Fridays I do a video. So, I've got a whole week here to get things all sorted out. So until the next stream, I guess I'll see folks later. Like, comment, subscribe. Let us know if this is useful info and that you like it and you're getting good stuff from it, and we'll keep doing it. So until then, Tony from Adafruit. So I'll see you guys later. Thanks.